one of the reasons why I was thinking of doing LLMs, that is large language models, because when we talk of NLP, nowadays we also to talk about LLMs. So my presentation will be on these two topics, and we don't have any prerequisite for my presentation. It's just a very simple presentations, and I don't expect a lot of technical terms in this presentation. So we are going to cover some few subtopics in these presentations, the one I've just seen here. So let me just go straight forward to my presentation. So the first question which comes to our mind is, what is natural language processing? And of course, some of us may have seen different branches of AI. We may have seen branches like computer vision. Some of us may have heard of natural language processing. The way I want to put things very simple, for example, in computer vision, is we are trying to teach computers maybe to see things, or maybe to interpret images. But when it comes to natural language processing, we want to teach computers to understand natural languages. So my very simple, what I understand by NLP is how we process, analyze, and also produce languages. And some other understand is like the way I don't maybe I don't think if people are getting me clear.
We are able to hear you, except that people are joining with loud music. They want the meeting.
Maybe they need to join, and then they might need to mute, so that. So I want to continue. So some people may understand NLP as the way computers interact with languages, but also it also involves teaching computers to understand, interpret, and also generate human languages. So that's the simple way of understanding NLP. So what are some of the applications of NLP? Because we need to understand why we need this NLP, why is it useful, and why are we making a lot of advancements in building some maybe sophisticated NLP systems. And some of the application of NLP is like text generation, where we have like now NLP systems and models which can generate a very relevant text. Maybe, for example, ChatGPT can just generate a very sensible language, kind of text which looks like it was written by a human being. And of course, another very applicable use of NLP is in machine translation. For example, you can give these systems a text in English and expect it to produce another text in Swahili. And also another application is in text summarization, where you give these systems very big documents, all big kind of text, and you expect it to do a summary. Maybe, for example, you are reading a paper which is like 10 pages long, and you're able to give this system this paper, and it's also able to generate sensible summaries. So another one is in text classification. For example, in NLP, we talk of sentiment analysis, where, for example, for people who watch movies, the NLP is applicable, where it can automatically maybe assign a kind of a label to a movie. Maybe the movie is bad, the movie is good automatically. So this is what we call sentiment analysis. Maybe you are able, given maybe kind of text, you are able to see if it's positive text or negative text automatically without needing a human being to go through. So, and another one is in of application NLP is in question and answering, where maybe you can ask a question, and then you're expecting to get an answer. Maybe you can ask NLP system, what is the capital of Nairobi, of Kenya? And then you are going to expect an answer like Nairobi. Maybe what is the capital of France? And you get an answer like in Paris. And also in speech recognition. For example, when you watch, in what we call the automatic speech to text. And this is, for example, when you are watching YouTube videos, it is able to produce some kind of text there from the sound, or maybe from the voice, and get some text. So that's one application of NLP, where you are able to get some kind of text from the from the speech, then text extraction, among others. So we have so many applications, but I just needed to put some few applications. So one thing which we really need to understand is why NLP is so hard, because you know, the way computers understand language is different from the way people, human beings, interpret language. For us, human beings, language is quite straightforward, but for computers, it's not like that. So this is a very big challenge when it comes to understanding NLP. And people have invested a lot of resources to try and see how we can deal with these challenges in NLP. And I've decided to pick like 3 challenges for the sake of clarity. So number one, NLP needs a lot of context. As in human beings, for you to get a quality text and sensible text, NLP always needs some good context. And also when you are training this like NLP system, you also need to train this system to understand or to generate kind of text from kind of context, so that does not give hallucinations or does not give irrelevant kind of did not generate some irrelevant text. Then it also needs a lot of domain knowledge, because we expect the way this system generate text in when we're in maybe medical domain should be different from the way this system generate text when we are in social domains. And that's a very big problem, because this kind of system, they are not able maybe to differentiate. So it needs to be taught on how to do this. For example, I give an example here of this human interacting with a bot, and he's trying to ask for flights and how the flights cost. And for you to get the answer of this question, this kind of system will need some kind of knowledge to know how to respond to this. And sometimes this is not always available, and it's also very possible for the bot to produce a relevant answer in the next kind of question. Then another very big problem in NLP is what we call ambiguity. So for human beings, sentences, they are usually very straightforward. And when it comes to computer systems, it's not the case always. Because for example, if I say, right head, 6 arms, these sentences can, ambiguity means where a sentence can have like 2 meanings. And it's not quite obvious for computer to be able to process and maybe get these 2 kind of meanings. For example, if you want to say, these guys, Steve and Manzi, are married, for human beings, processing this is straightforward. But also it can mean, this sentence can have like 2 meanings, where it can mean that this guy and this person, they are married. But also it can mean Steve is married to someone else, and this girl Manzi is also married to someone else. So for human beings, they are able to reason in this kind of direction. But for these NLP systems, it's not quite easy, all obvious for them to reason like this. So it becomes a challenge. Or maybe if you say Mike kissed his wife and so did Jay. For human beings, we have like 2 meanings, where it can mean that the guy called Mike was trying to kiss his wife. And also it can also mean Mike was trying to, in this sentence, it can mean that Mike kissed his wife and also Jay kissed his wife. But it can also have another meaning depending on how you want to interpret the sentence. And for this computer system, they don't usually do language like that, because usually they learn to reason from, they learn to generate text from kind of what you call training data set. And it's not usually straightforward to generate this kind of sense. And also maybe if you say, I saw a bat, this bat can also have 2 meanings. So that becomes a challenge to try and teach this computer system to reason the way human beings are reasoning. So these are some of the challenges which people are working very hard to try and address. So then again, maybe I want to get on how people usually do processing NLP. So usually when we are doing NLP, it's usually not that straightforward, because because of the way the data is usually collected. So most of the data in NLP is usually unstructured, and by unstructured, I mean it comes in very different forms, and some of the form is not usually ready for analysis. So it has to go some standard kind of processing, what we call pre-processing, for it to be in a kind of a format that we need. So I just want to touch some of the practices, some of the kind of methods or the techniques which people usually do to make this text, which we have maybe gathered online from textbooks, from Wikipedia, to make it ready for kind of natural language processing. So one of very obvious things that people would like to do is to convert this. So before this, what we usually do is when you are maybe you want to create this natural language processing like systems, you have to come up with what we call a training data set, like a data set which will teach these systems on how to maybe to generate text. Maybe you can go to Wikipedia and get all the text there and use that text to create these steps. So that's actually how people usually do. So, and one of the practices people usually do is to do what we call lowercasing. You just take all your text and you convert everything to lower cases. So for example, this word, you convert the capital letters to small letters that it becomes. So it's like a standard way of doing it. And the reason why people do it is because we just want like a kind of standard text, because changing it from this format to this format, you don't lose a lot of information. But obviously you have to do it very carefully because you might lose some small, maybe piece of information, but usually it's a very a powerful kind of technique in NLP. Then we have another way we call tokenization. So usually NLP, usually computer system, they don't process a whole sentence. Like if you want to process the word, my name is Steve, for human being is obvious, but for the computer systems, they usually do it word by word. So they somehow break this word, like hello, how are you today? They somehow break this into this kind of tokens, so that the computer understand this word alone, understand this word alone, instead of understanding the whole kind of sentence. And this is called tokenization. So usually this is what we call tokens, and this is the process of doing converting sentence to these like words. Like this one is called tokenization, but usually it's not always like words. Sometimes it can be subwords, but tokenization is like an independent kind of research area. But for the sake of being simple, let's just assume like in this case, tokenization means changing this kind of sentence to these individual words. Then we remove punctuations to make the text to be in a kind of standard way, because having this word and having this word does not change a lot of things. But punctuation, they are usually very relevant in this kind of text, in this kind of NLP maybe systems. Then we remove stop words. Like if you have like big corpus of data, the word there and this becomes irrelevant, and deciding to drop this common stop word like there is won't change a lot, but it will make you to have like very sensible kind of vocabulary. Then we have stemming and lemmatizations. Instead of having the word going, you can change it to go and use this as your training data. Then same as removing these URLs, HTML tags, spell corrections, making sure that, because what you teach computer is what is going to understand. So you have to make sure that you don't have like spelling errors and so on that. And also we have to do normalization. For example, if you have a data and in your data, the word US to mean United States appears, and also you have United States appearing in your data, you can decide to use US to mean this, or you can also decide to have United States to mean this. Instead of maybe every time having US and United States in your data, you can just maybe decide that I'm going to have United States alone and drop US. And when I was talking about lowercasing, and I said we have also to be careful how we do it, the word US in capital letters and the word US in small letters actually may mean two different things. So we have to do lowercasing and also normalization in a very careful way. And we have another technique called padding and truncations, where padding you might decide all my sentences will be like 10 words long. So you put them maybe the length. So padding and truncation have something to do with the length. Maybe you decide all my training sentences will be like 5 words long. And if it's longer than that, you cut, like you separate them. That's called truncation. But if they are smaller than that, you find a way of making them to reach that kind of length. So I want to take you through what we call language modeling. So how would we model these languages? So this language modeling might need some small understanding of how probability works. So the idea is learning the probability distribution of text. like the idea is trying to understand how do two words in a text appear together. For example, if I want to say I am teaching, there's higher probability of saying I'm teaching maths than saying I am teaching food, because the word teaching is more relatable to maybe teaching maths or science than maybe relatable than saying I'm teaching food. So this is how we do language modeling. You have to see the probability of predicting a word given the previous words. And these previous words, sometimes we call them context. So you want to see, given a context, what the probability of getting the next word, the N words. And usually this is take the format of what we call probabilistic language models. For example, we have probability of getting a word at this time, given the previous words, depending on the vocabulary. So vocabulary means the unique words in your training kind of sets. So for example, this becomes your WT and this becomes your context. So what you want to see is what the probability of getting I'm driving a car, I'm driving a, what the probability of getting car given this was the test sentence. So what you usually do, you get your vocabulary and you are going to like sort the probabilities. So maybe a language system can say I'm driving a car, it gives it probability of 0.9. I'm driving a boat, 0.2. Maybe I'm driving what else can you drive? So you give them probabilities. Maybe let's say I'm driving a car is 0.5. I'm driving maybe something like I'm driving a boat 0.2. I'm driving a ship maybe 0.3. So you want to see the probability, and we expect the word I'm driving a car to have a higher probability than the other kind of the kind of words. So I also want to talk about how can I put this? Ooh. Okay. So I want also to talk about what we call n-gram language models. So n-gram language models usually work the same as the probabilistic language model I've just introduced. But what matters is what we call the window. Sometimes you want to predict the word car and you decide your window is 3 words. Some other people can give it a bigger window. I'm driving. You want maybe the response will be car, and then you give it maybe a very big window. So that's what we mean by n-gram model. In this case, our window is like 2, like 3, because we are using 3 words to try and predict the 4th word. Yeah, but also we have like other ways, techniques of estimating these n-gram probabilities, but I think this is more advanced than what I was planning to present. But also, so n-gram, I can all these n-gram, all these probabilistic models, they are somehow like traditional NLP methods. But nowadays, people are more of doing machine learning instead. So maybe if I can talk of what we mean by machine learning is where you are training maybe a system to to be able to to able to uncover some complex patterns from data. So use like machine learning is the system learns from experience to maybe to make predictions given some data. We call it some training data. So, and this is usually very crucial because it helps us to go deep and also helps us to get into understanding some complex patterns in languages. Because as you know, NLP languages, they are very complex. And this alone cannot be enough for us to understand how languages work. Because imagine we had like 1 million kind of text like this, and we have to predict this. So for machine learning allows us to go deep and to uncover some very complex patterns in data, which maybe human beings cannot see or maybe human beings cannot understand. And what we usually do is try to convert our problem like this into a machine learning problem. And by converting this to a machine learning problem is we have to come with a technique of trying to teach this system. Every time you see I'm driving a car, give it a higher probability to. Every time you see I'm driving, give it a higher probability to the word car. And this may involve coming with things we call cost, where you are going to penalize this model when it makes a mistake, and you are going to maybe to kind of teach this model to understand this is how you are going to produce text. So you have to like these ML techniques and define this problem in this way that the model can understand to associate these two things with higher probabilities. But also one thing which is also good to mention is, which is very important, is like these models, these computers actually, they don't see languages as text the way human beings see. Like if you have the word, you have this, for example, you have the word, maybe let's say let's give an example, let's say this sentence, computer will not see this the way you see it. So you have to find a way of converting this into numbers. So computers will understand numbers, but not text. And one of the techniques people usually use is we map text into vectors. So maybe vectors, you can think of matrices. We are going to, if you have the word car, we are going to map it into a vector. For example, the word, if we have let's assume this is our sentence that we are trying to understand. The cat sat on the mat. Because the computer will not understand this word, we have to change it into numbers like the one you have seen here. So the way you usually do is one of hot vectors encoding. So instead of having the word there, the computer will understand this. Where there is there, you put 1, and otherwise you put 0. So this is what you feed to your model. This is what we call a vector. This 100 is what you put, what the computer will understand, but not the word there. So the computer, instead of understanding the word cat, will understand this kind of vector. So that's what we usually do. But this is quite simple. It's more complicated than this, and I think it's more advanced. So instead of using one hot kind of representations, we have other representations we call bendings, which they make more sense than this. But I think that's something we can discuss another time. But just understand the way we do it. Computer, they don't understand word by word. They understand we find a way of maybe trying to map these words, every word to be like a vector. Then I want to discuss one very important thing in NLP, and it's called RNN. So RNN, I don't know, maybe some of us have not come across neural networks, but what neural network does is, neural network is the engine behind artificial intelligence. So the idea is to try and try and copy what the brain is doing to understand things. So the idea is to make systems try to do things the way brain does it, and that's give the rise of the neural networks. We have like neurons, some kind of connected networks, which enables those systems to process information in a very advanced way. So one of the variant of neural networks or maybe those AI is what we call an RNN. And this has been the kind of distinction between those traditional natural language processing techniques and the advanced techniques. So what RNN does is maybe it's a special kind of it's like a special case of neural networks in which it like processes every word alone, and then it has what we call like a memory. So if we have a sentence like this, let's give an example. We are processing a word like this. What RNN does is it will take this sentence alone, probabilistic alone, then it's going to process it. Then what it does, it kind of encodes what this word means, and it has what we call like a memory, which stores that it has learned something called probabilistic. That's the knowledge. Then after that, it goes to the next word, language. So when it reaches to this word, it has like kind of another memory, which is it updates. No, in this case, it has this knowledge and this knowledge. So this one you call the current state, and it depends on the current input and the previous kind of input. So when it is here, it has another new knowledge. So it makes it to understand these two words. Then after that, it goes to the third word in the sentence. And now it creates another new understanding. And this new understanding is combination of understanding this state and this state. It goes on and on. Maybe our sentence was like all this. By the time it reaches here, it has a new understanding of the whole sentence, which is combination of every kind of single word. So that's how RNN works. It's more advanced than this, but that's the idea behind how RNN works. And they are more useful in time series kind of data, maybe sequential data, which follows the way I was trying to explain. Yeah, so then again, when we are training this computer system, we have to find a way of trying to evaluate how they are doing well. It's like you have to give them an exam and see how they are, how well they are doing. So these are some of for the people who are willing to who are curious in understanding more about NLP, these are some of the evaluations we always come across, like accuracy, F1 score. We have this one we call blue score. So blue score, maybe I can talk about it. So blue score is very common kind of metric, maybe to evaluate machine translation task. So machine translation task is where you give a sentence in English and want to see output in Kiswahili. So what we usually do is we have what we call a reference. A reference is what we want this model to produce. And then we have their prediction, what they are predicted. Then we have some calculation they do, and then they give a figure. So when the blue is big, because the blue score ranges from 0 to 100, when your system has a very big blue, it means that your system is good. But when it has a small blue score, it's not doing well. For example, in this case, blue score was 17.6. It means in this case, when this system is doing from English to Swahili, it's doing it better than doing from English to Kinyarwanda. So this is an example of blue score. It's quite common in machine translation, among others. So, but I also wanted to talk about transform architecture. For people who will be doing a lot of research in NLP, all those who are interested in doing work in NLP, you'll always come across these transform architectures. So
Hello?
maybe, yes, sorry.
Hello.
Yes.
Can you go and talk on the perplexity?
Okay, this one.
Yeah.
So, okay, so perplexity is another evaluation in NLP where you want to see how the model are generating new text. So this is designed in a way that it's going to differentiate from just a random text and a sensible text. So if we give a system, maybe after we have trained a model and we try to evaluate using this perplexity, and it gives a very big score, it means the model is not doing well. You have to find a new ways of trying to train the model to get a better understanding. For example, if I was to maybe compare 3 models, maybe one called unigram, bigram, and trigram. And after doing this is like some complex mathematical calculations, and I get these figures. In this case, it means this model is doing better than this one. So it means this model can be improved. So that's what it does. So we use this evaluation to see how well our models are working. So if our model are not working very well and we are using this as our evaluation metric, we are going to get a very big score. It means we can continue training, we can come up with new techniques of making this low, because the lower perplexity means better models. Yeah, but I also want to talk about these transform architectures. They are very, very important. Yes.
Before you go to the F1 score, precision and recall, can you draw a little light on it? Precision and recall.
Okay, precision and recall. So okay, precision and what we call accuracy, they are more of related. For us to really understand our precision and recall, we might need to go and check another table we call confusion matrix. So there's a specific formula of getting this precision. Maybe there's a specific formula of getting kind of precision and also getting this recall. But I think I'll share the formula later. But there's a formula of getting this one and also getting this one. But they are somehow related on how you get accuracy. For example, accuracy is where we have maybe you give an exam of 10 questions and you score 7. So your accuracy will be 7 out of 10. That's your accuracy. Precision works in the same way, but the formula is somewhat different from this. But I'll get it and then share with you. Sounds good?
Hello.
Yes.
Can I ask a question?
Yes, please.
In the first table, we have something like 10-shot prompting and 1-shot prompting. Can you?
Yes, I'm going to talk about this later in my presentation. You should not worry. Okay. But it's not for this, for the sake of Blue Score, it's not quite relevant, but I'll talk about later. So I want to talk about transformer architecture. So transformer architecture is quite, I think this the best thing which happened in NLP. So this is a technique which was introduced by Google, and it has been the technique behind the good performance of things like ChatGPT, Google Translate, and all those things. So I think it's a good way to spend some time talking about what is transformer architecture. So transformer architecture was introduced in June 2017 by Google researchers. You can see them here. In a paper they call Attention is All You Need. So I'll advise you people, if you have time, you can go and check this paper. So can we see my, I think this is blocking my, I don't know how I can put it. I can. Okay, good. So I was saying the transformer architecture was introduced in this paper, Attention is Also You Need, and it's the architecture which has transformed the whole field of NLP. So they introduced a technique which they call the self-attention. I'm going to describe what we mean by self-attention. But the idea was there was challenges in NLP trying to understand the context of the world and trying to see which words in a sentence make sense. So they came up with an idea which they call self-attention. So this self-attention, it allows the model to weigh importance of words in a sentence. For example, let me give an example. I'll give an example later. So if you are given a sentence, of course, some words in a sentence, they don't usually make a lot of sense. So the idea is to see which words in a sentence makes it to make some sense. So I'm going to describe further the meaning of self-attention as I continue my presentation. But how the transformer works, one thing about transformer is it resulted into improved performances, like set of the hard performances. It beat all traditional methods. It's also beat the RNN method. Every method which was existing before 2017, you could shown some improvement when they used the transformer. And also it resulted in great speed because we could use what we call viralization. So this means instead of the model taking word by word at a time, it can take the whole sentence and try and process it. Usually it was used in machine translation, but now it is used in all other NLP tasks like summarization, all those tasks which I've described before. So what happens in transformer is you just take an input, which is like a sentence like this, and you pass it through transformer like a black box, something like this. Then you are expecting to get kind of output. In this case, this is a sentence in French, and it passes through this complicated transformer architecture, and then you get an output in English. And then it has what we call encoder and decoder. So encoding is you get this sentence and you try and make sense of this sentence. What does it mean? Then after that, you pass it to decoder. This decoder, they generate a text, and this text you get it. So it's like you get the word, this word, you pass it through these transformer encoders, and it generates understanding of this word. And you tell the decoder that you want to produce another text in French. So it does. So we have encoder and decoder. But that's just a high-level summary. So it's more complicated than this. But if you want to read more about transformer, here we go. Now, why are these transformers very, very, very important? Because in NLP, if you have one like this, the animal, this is an example I took from their paper. The animal did not cross the street because it was too tired. For human beings, if you see the word eat, it's quite obvious the word eat is animal because the animal was tired. It refers that the animal did not cross the street because it was tired. So for human beings, you always associate the word eat with the word animal. But for computer systems, they can associate it with the street. For us, it does not make sense to say it was a street. But for computer system, the word animal and also the word street, they almost carry the same weight in the decoding the meaning of the word it. So what the self-attention does it comes when it processes the whole sentence, but when it reaches to the word it, for example, maybe it can be any word, but for example, let's say we are talking about the word it. It comes here and it says, this it can be referring to two things, either the street or the word animal. So what it does, it gives the word animal a higher value or maybe more importance than the word street. And this makes the transformer to understand that it in this case refers to animal but not street. So every time it sees the word it will kind of develop kind of understanding to associate the word it with animal and associate it less with the word street. And this has proven to be very, very important because it makes this system to understand this sentence better. So this is how it usually does. It will process every word alone, but when it reaches to word it will learn, because there's a way they train this model, it will learn that the word it is more associated with the animal, but not the street. So by doing so, it will get a very good understanding of the word of the whole sentence. This was the challenge in the previous kind of architectures, but when the transformer came, the problem was almost solved. Now, in the second part of my presentation, which I'm going to take less than 10 minutes, I want to describe what we call large language models. And when you talk about these LLMs, they are more of product of this transformer architecture which I've just described. So LLMs is just AI models which can generate and understand human languages. And of course, every one of us maybe have seen, or most of us have seen how the ChatGPT does. ChatGPT can be a very good example of language model. It's able to understand. You can be able to ask ChatGPT questions and generate some very sensible kind of text. So the LLMs, they are able to produce text which looks like as if it was written by human beings. So it's just think of very complicated models which are able to understand human languages. And I have already said that they are built on this transformer and components with self-attention, which allows us to understand the contribution of every word in a sentence. And as you go through these LLMs, you'll always find these few terms: pre-training. So pre-training is where you train this model on a very huge or massive text, so that it learns like general language, like representations. Then after you have trained this model, you do what we call fine-tuning. So you take this model which you have already trained, and then you teach it on maybe another specific kind of data, so that it gets to understand the given downstream task. Then pre-training is supervised, more of self-supervised technique. It means that we don't have labels, but the model is able to create its own labels. Yeah, so if you understand the way supervised works, and then we have unsupervised kind of techniques, then we have another technique called X. But this is more deep, but if you have any question, I can go deep on what we mean by self-supervised. Yeah, maybe if you want to understand well what pre-train means, is like the way human beings really understand language, understand things. Maybe if you want to understand something very well, you need to read, like maybe if you need to read widely about something. Then if you want to read to understand it better, you have to go deeper in that thing. So like pre-training, you tell the model to understand like general languages. Then you fine-tune it. You tell the model, now I want you to understand how to do machine translation alone. Or maybe I want you to understand how to do summarization alone. Because ideally, when you are pre-training, you train this model to do like very many tasks. Then after that, you can also train it again to do one task. Examples of LLMs is the first LLMs to come after the transformer model was called GPT. And then afterward, we had another one was called BART. And GPT has progressed until now we have what we call GPT-4, GPT 3.5, we have T5, we have Palm, and so on and so forth. But if you want to really understand, to get to see all these models, you can visit the Hugging Face. This is where all these models are there. All of them, they are there, how they are trained, how they did training, the code and everything.
Stephen?
So yes.
Sorry for interruption. Someone is asking, how is pre-training self-supervised? Please expound.
Okay. So okay, let me explain this. So when you are pre-training a model, is what they usually do is they take text from all over the internet, from the article, Wikipedia, everywhere where they can get text. They collect this text from the universe, like any available text that they can get from Wikipedia, from books, from Bible, everywhere. So when they are training model, what they usually do is they train this model to understand. For example, they can train this model. For example, let's give an example of the word I am going to school. So they don't give a label. Like, for example, they don't give a label to that text. So they can, for example, decide to, if they are saying I'm going to school, they can come and they use another technique called masking. So they tell the model, I am going to. Then you are going to train this model to understand that when I see the word I'm going to, you are going to associate it to school. So that's one we call it like masking. You mask, like you cover, like you remove some words, and then you teach these models to somehow generate that masked word. And also they are also self-supervised because, as I've said, you don't have like given labels. You generate your own labels. Like, for example, if you want to say maybe I am driving a car, when you first train, you get the word I am. Then you train this model to see A. Then after you have the word I am, then you train the model to say after the word I am, it's the next word they can predict this training. So like in short, self-supervised, like you do have labels, but somehow you can be able to create these labels using some techniques like masking and so on and so forth. I don't think if it's clear. So okay, let me continue then, but if it's not clear, I'll come back.
No, you're
So-
good. You're good.
Yeah, so this is Hugging Face is like models. All models you can find, NLP models which are based on transformers, you can find them here. And you can take any model here, you can train it, you can pre-train it on a specific task. You can also get codes, you can get the papers, everything. So this is like the largest platform when it comes to NLP. So now I want to talk about the sizes of these models. So the sizes of these models means if a model is big, it means it is also capable of doing like very many interesting stuff. For example, the biggest model nowadays is PALM. PALM is a model from Google. It was released in 2021. It's like 504, it's massive. It's like 540 billion parameters. Then we have other models like ChatGPT and so on and so forth. So the more the model looks to be big, the more the model is able to do many things. For example, a model like PALM can do translation from one language to another. It can summarize, it can generate text. It can do many stuff. It can even do stuff in medicine, it can take exam and pass. So it is quite, it can do like, the capabilities is quite big as compared to smaller model like maybe like this one. So I want to also to give a more specific example of LLMs. The biggest LLM like language model present is PALM, which is like 540 billion parameters. This is quite massive. It's big, like it's bigger than you might imagine. It was developed by Google in 2021. It was trained on 716 billion tokens. You can imagine like the sentence, like the words which were used to train this model was like 716 billion tokens, like huge amount of very, very huge. It's like the universe of text, the text which is available online everywhere in the internet, it was used in the training of this model. Then we have GPT-3, which was developed by these OpenAI people. It was 175 billion parameters. It was trained on 300 billion tokens. And one of uses of this model, this ChatGPT, ChatGPT is a product of GPT 3.5. And then you have BART. Yes.
That's the amount of data used to train, or the amount of parameters.
Sorry?
That the amount of parameters or data used to train the model affects the performance of the model. Does it have any corresponding?
Definitely. Like if you train a model on a massive data sets, like this is a very massive data set. The parameters are more like, it's like weights, the knowledge it has acquired. So if you train it on a very big, like massive tokens, massive data set, the model will be big and you'll have like these kind of parameters. And this model will be very powerful. It's like, as compared to another model like BART, which was only trained with 3.3 billion tokens. So if I were to compare BART and PALM, this is like the capability is quite big as compared to BART, because the more you see, like the way this thing works is like, if you have seen a lot of information, you are most likely to remember more than the person who has seen less information. Like if maybe I give an exam, someone who has seen a lot of information, a lot of materials, you are going to perform better than someone who has seen little materials. The same things. So Palm, when they are training this model, they get any text which is available and they use for training. And because the model has seen almost every text which is available in the internet, in the books, articles, Wikipedia, it's able to do quite well. So yeah, the question, to answer your question, yes. The bigger the model, the better it does. And the way we assess the capability of models can be the number of parameters. Like if you have like 540 parameters, will be more powerful than this model with 340 billion parameters. So these are some of the examples. And then we have another one from a large language model from Meta AI, this one. And also we have this one, this is the most recent from Facebook. Then you have GPT-4. So GPT-4 is the modern kind of version of ChatGPT, and it's called Plus. So the idea is these big companies, they're like trying to see who is better than the other. So it was GPT, produced ChatGPT. Then the Google came with another kind of version of ChatGPT called Bard. Then Facebook this year have come with their own, which was based on this model. Then I can talk about the applications of LLMs. Where are they useful? Why are people using a lot of resources to train things like ChatGPT and all this? Because it takes a lot of resources.
Hello.
Yes.
How do you get access to the Palm? Because is it in the Google Bard? The Palm.
Oh, yes, correct. The Palm is the one which was used to create Bard. If you have used Bard, then you are using this model.
Because people try to compare the GPT-4 and the Bard, and it seems like the GPT-4 seems to outperform the Bard. I don't know.
Yes,
I don't know if
what we are saying is true. People try to compare the Google Bard, which was based on Palm, with the OpenAI GPT-4, which produced ChatGPT, and it seemed like the ChatGPT to be more powerful. But when you are trying to see which one is powerful than the other one, you have to check many things, because this Palm is also capable of doing other interesting things, maybe in medical, in health, and in other things. It has done exams, it has passed exams. So I can say ChatGPT and Bard, they're almost in the same level. But it seems like people like this.
Please, a follow-up question on it.
Yes.
Yeah. I think you've answered some of my questions in the presentation, but then I've observed that some of these AI, they are very poor in mathematical stuff. And you see sometimes you query them and they give you wrong answers. I don't know. This Palm, GPT-3, and all this, which one do you think is best in mathematical stuff? And how do you think is the best way to query them when you want to get responses based on mathematics?
Okay, now, now I'll be, okay, I want to take like 2 minutes to explain how which one is better than each other. So I think Palm, so one thing you have to know to find a technique of making this model produce the kind of output that you want. So what people usually do is what we call prompting. Prompting is sorry? Sorry? Okay, let me explain. So when it comes, someone is saying this model, they are not very good maths and all those stuff. But I've seen ChatGPT is doing equally well in mathematics, and also in Palm. Palm is also doing well in mathematics. But what matters is how you are going to tell this model to do what you want to do. And we do that by what we call prompting. There's a way you are supposed to format your question so that the model understands what to produce. So you are supposed to explore different way of prompting, like telling this model, this is what I want, so that for you to get this kind of response. But for ChatGPT, it's quite straightforward. You just tell it I want to do this kind of maths, and you make sure that it's clear, and the way you are maybe formatting your answer, and then you are going to get the kind of response you get. And also, PAR might not be good in maths, but it's good in other kind of tasks, because it can answer questions, it can do other interesting stuff. But ChatGPT, I have tried it in math and it does well. Maybe you need to change how you prompt it. Prompting is how you ask the question. The keywords you use is what makes this model to respond in a way that you want. For example, if you want to ask a question in maybe multiplication, there's a way you have to make this model understand that the question is more about multiplication. So it's called prompting. Yeah. And also maybe another way of prompting is maybe you give it few sentences, and after that, you expect the model to continue. So that's why you're prompting. So yeah, I don't think if I'm clear.
If I want to follow, if I following up with the question,
Yeah.
I queried I once queried Bing, which is also based on GPT-4.
Which one?
Microsoft Bing Chats,
Okay,
which is
okay,
also
yes.
Bing AI, which is
Yes.
based on GPT-4.
Yes.
There was a calculation, and it was supposed to calculate 6 out of 3, and the answer was 1.5. What I understand about this model is that sometimes you feed it with information like, okay, you have mistaken or something. So this is the
yes.
try understanding 2 times 3 gives you 6. So the answer is not 1.5. But it was rather arguing that I am rather mistaken that 6 divided by 3 is 1.5.
Yeah, okay. That's
so,
sometimes. Yeah, sometimes it happens because maybe when because I think that Microsoft Bing, they fine-tuned this GPT, they did like fine-tuning. Maybe it did not learn very well on how to do this kind of divisions task. But I'm sure maybe ChatGPT itself can be able to solve that kind of problem. Maybe you can try ChatGPT itself and see.
Okay, thank you.
Yeah. So one of the applications of LLMs is like these LLMs have become like everyone that in town is talking about this LLM because of the kind of things they can do. They can do anything in language that human beings can do. For example, they can do machine translation. Now it's possible to translate from English to French, from Kiswahili to English, all those things because of this. And this becomes useful when you go maybe in a country where people don't speak your language. Maybe you don't know French and you go to France. You'll see why this machine translation, they are very important. Or maybe in question and answer, you ask ChatGPT, which is the capital city of Nigeria, and you are going to get the answer. Maybe you want to learn something. Summarization, you have a very big article. For people who are in school, you have a big article and you just want to get summary. These models are there for you, and they become very, very useful. Then we have chatbots and these virtual assistants like Siri. For those people who Apple product, they know what it does. Content creation. This model are able to do creative writings like Bard and ChatGPT. You can ask them, tell me a joke. They are going to do that. Sing me a song. They are going to give you a very interesting lyrics. Maybe give me some ideas on how I can talk to a girl. They are going to give you some very relevant information. So content creation, they can create any kind of content for social media, for anything, for school, for anything. They can also do, when you are code bugs, maybe you are writing a code in Python or in R and you are getting error every time. You need to copy paste and put in ChatGPT and it can debug for you and you are good to go. Your problem is solved. Also in medical and scientific research, they can be used in research in medical. They can also suggest maybe a medicine that given maybe a disease. They can assist doctors to make decisions and so forth. For example, in this example, I was telling this ChatGPT to give me a code for transformer, and here we go. If I was doing an assignment, I have the answer. So we have challenges of LLMs. They are very, very, very expensive to train. The word very is understatement. They are extremely expensive. For example, when you are training ChatGPT, it took like billions of dollars to train it. It's very expensive because it takes a lot of information, a lot of text. You have to have good software engineers, data, all those people, researchers to train this model. And also powerful computer is very, very expensive too. For one to get something bad, something like Palm Balt is very expensive. And also hallucinations. My friend I was talking about getting wrong answers. They also sometimes give wrong answers, what you are not expecting. You ask your LLMs, what is 6 divided by 3, and you get 1.5. Then you are surprised, what is this? This hallucination. They give you what you are not expecting. They just give an answer for the sake of giving an answer. Then we have ethical concerns, biases. We are not expecting to see biases in language models, but they do. They do show a lot of biases, which becomes a challenge because the biases in the training data, we don't want to see them in the text which is generated. Then in environmental impact. Like if we were to do models like ChatGPT or Palm and we do 100 of them, it is very harmful in to the environment. It's like training one ChatGPT model is even more than driving maybe 1,000 cars. So you can see how they contribute to, and now we are living in climate change crisis and it becomes a global concern. These models, they produce a lot of CO2 when they are training. Like when they were training ChatGPT, a lot of CO2 was produced. It's equivalent to driving 100 cars in town. And they also lack common sense reasoning. It's called artificial intelligence. It's not natural intelligence. It's only human being who can reason. This model, they try to reason because they are trained with massive data set, but they always lack common sense. Because this model, they are not human beings. They are just generating text given the knowledge they acquired when they are being trained. So they always lack this common sense reasoning. So what are people doing? What next? People are now building larger models. I've shown you when ChatGPT came out in 2021, Google went and produced BALD. Last month, Facebook came with their own model. So this big Microsoft is coming with other models. People are like building larger models. And we are going to see model beating new model which are going to beat these 540 billion parameters which was using Palm. So every company, before it was this, then we had Palm, then we had this, and more and bigger models are coming. So people are beginning to pay more attention on ethical and bias in these LLMs. We need to have LLMs which they don't show any bias. Like there's nothing like they don't show discriminations, because there's a lot of discrimination, biases, harmful information in text, and you don't want to see this in models like ChatGPT. And also this interpretability. We want a model to give an output which we can understand, not just why the model came with this kind of answer. Before a doctor needs to make a decision using these large language models, he needs to understand why model decided to give this kind of response, but not another response. Yeah, so
Hello, a question.
Yes.
Hello, a quick question.
Yes, please.
Yeah, there are some that claim to humanize results from ChatGPT.
To do what?
I want to know, some AIs, they claim to humanize responses you get from, let's say, ChatGPT. I want to find out, are they not also working on the principle that ChatGPT works, and do they really humanize, or they just change the language?
I mean, I just think they just transform the output. I don't think it's possible to humanize, because if you think of now this model they are trained, it's very hard to humanize them. Maybe you can come with very complicated, very sophisticated kind of methods, but I don't think it's possible. But they try. Maybe they try to do that, but they cannot really do that, because this model, the technique they use to train this model is just based on text and the data which is available online, which is maybe a reflection of how people think and how people write. So it's not quite very easy to do that, but some of them, they are doing very well. They're in the right direction of doing that. But I don't think where we are now is not very easy for us to humanize it, but they are in the right direction. They are trying to do that, but they are not 100% there. So my last slide is about NLP research. For people who are
before that, a quick one.
Yes.
How do you customize maybe a large language model like maybe ChatGPT or like with your own data.
Yes.
You talk about Hugging Face where the models, can we get the models there to train them with your own data, and so that to be giving you responses based on the data you have trained?
That are very good
And
question.
what process you go through?
So that's a very good question. So what usually people do is, if you go to Hugging Face Transformers, the one I've just shown, Hugging Face Transformers here, you find so many models. And then you need to use some information to know which models is used for what. For example, I can find a model like PAM, and I know PAM can be able to do something like machine translation. So what usually people do is, this model, they are pre-trained, so they have general understanding of the language. So what we do is, we do what we call fine-tuning. So you take that model, so these Hugging Face Transformers, they have what we call weights. They have the weights of this model. So what you do, you come with your 1,000 sentences, which they are labeled. In this case, labeled means that you have a sentence and you have what you expect. Maybe, for example, if you are talking about machine translation, you want to translate from English to Yoruba, maybe for people in Nigeria. So what you usually do is, you find like 1,000 sentences which are in Yoruba and English. Maybe a sentence in English, Yoruba, English, Yoruba, and you have like 1,000 text, 1,000 data set examples. Then you need to write some code in Python, and you are going to tell this model now, what I want is, because you have been trained on many tasks, I want you to fine-tune you to do machine translation in this format. So the model will be able to learn to adjust its parameters. We will be able to learn when it's given English test is supposed to produce a Yoruba. So you just go take the weights and use some Python techniques, and maybe you train it further. It is quite easy to do that. You train it further, and the model will be able to understand, oh, now this guy wants me to know how to translate from English to Yoruba. And after training with those answers, the next time you give it a text in English, it will be able to do that translation. So the idea is to use what you call fine-tuning. You take that model from this model zoo, you come to the Hugging Face Transformers, you look for the natural language processing, and there are so many models. There are so many bad, all those, even this from Meta, they are there. So you take that model weights, you go and fine-tune it. You might need to know some technique on how to do it, but it's possible. So it also needs you to have some data, a very high quality specific data for the task you want to do. So if you want to teach this model now to do machine translation, you have to give it a text which is translated. Then from that it will be able to learn how to do it. If you want to teach it to do what we call text classification, it means that you have to give this pre-trained model another enough examples of how to do text classification. It will be able to do this. Another technique which people use in ChatGPT for the task you want to do is what we call prompting, and what we call few short kind of prompting. So you go to ChatGPT. Let's say I want to get translation from English to French. So what you do, you give the model like 10 sentences. Maybe you say English, my name is Steven. French, the translation of that word. You give the model like 10 sentences in that format. Then you give the model like another 10 sets of sentences that you want you to be translated, and the model will be able to do that. So that is called prompting. But the most of this model, they go by this fine-tuning. You take a model which is available here, you use some simple Python techniques, and you somehow train this model again in your data set, and you'll be able to do that. It's like the way we teach ourselves. Like, you take a model, because I have a general understanding of how to do maths. You only need to tell me, I want 5 plus 5 is 10, 10 plus 20 is 30. So the next, then you tell me 30 plus 30 is 60. Then you ask me, what about 50 plus 50? What about 100 plus 100? Then the model will be able to know what you want the model to do. So that's what we call prompting and fine-tuning.
Okay,
Yeah,
so the models are the Hugging Face, are they open source?
yes, they're open source. You can use them. You can use them. But for the ChatGPT, we also have the what we call APIs. If you want more detailed ChatGPT output, you can use APIs. But models in this, they are open source. Anyone can use them. You can use them for your own use, for your own task. Provided the task lies, the model is able to do that, the task you want to do, you can adapt them for classification, all these question and translation, all of them. You can do all this. They're open source. You can use them any day, anytime. They even give you examples on how to do it. They show you how to do it. They can even give you data. So it's quite simple. So you just adapt them. You just need to learn how to do it. And then they're open source. Anyone can use them, especially for people in research. But anyone can use them. But for example, for the ChatGPT, to get this one, you have to pay. But this one should be free. Yes, then we have, what are people now doing in NLP? People are like more of, these are some of the direction people have decided to take, what we call multilingual NLP. This is coming with systems which can translate from one language to another. For example, it's now possible to translate from, maybe if you are in, let's go to, if you're in Ghana, it's possible to translate from English to Akan. It's also possible to translate from Akan to Ewe. It's also possible to transfer from Twi to Ashanti in Ghana. Like we have model which can do this translation in any direction. It's not from English to your language. You can also be done from one local language to another, maybe from Twi to Ewe, and it does very well. And an example of this model is the model we call M2 M100. This model was produced by Facebook in 2020. And is able to translate between 100 languages in more than 1,000 directions. Maybe if we have like 1,000, if we have like 100 languages, we are able to translate from language 1 to language 10, from language 10 to language 50. So in any direction. Yeah, and I put this example intentionally because the people behind this work, like Angela Fan and this guy from Facebook, some of my former professors, and they did this work was amazing and it worked very well. Even for local languages like Yoruba, is there, Swahili, and other languages. So it works very well. Yeah. Then we have people are also working on ethical and accountable NLP, where you want NLP to be not to produce harmful text, harmful kind of output, and so on and so forth. People are now really working on what we call low resource NLP. So the idea is this: ChatGPT is able to do their work very well in English, but the question, can ChatGPT produce the same kind of quality text in your local language? Can we get good machine translation systems in languages like Kikamba or languages like Yoruba, Ewe, language like Hausa without any problem? Because for English, it works very well. What about for the other languages who are not represented in online? For example, can you create a content in Swahili without any problem? For English, it's simple. If you tell ChatGPT, write me a story in English, it will do that. But it will struggle to do that in Yoruba. It will struggle to do that in Swahili. So many people are working to see if we can adapt this. This advancement in NLP can be also assist us in our local languages. And our example of work I did this year, this paper I was doing this year with one of my colleagues, not my colleagues actually, with one of my friends, and we was trying to work on this resource of machine translation. And yeah, the paper is available online. You can see what we did with this guy from Google. Then we have another Masakan community. This is another community from people who are working very hard to make NLP for Africans. We want also NLP to be, we want to have a ChatGPT which can understand languages in Africa. And also I've also talked about Hugging Face. It's quite useful. I would actually advise people, if you have time, to go and check what this thing does. This is like a very useful kind of advancements in AI. It's quite powerful when it comes to NLP. So if you have time, you can check this. They even have some simple classes in NLP and so on and so forth. So if you have time, you can check that. then these are my references and also very small resources. You can go this Coursera course, you can check this how transformer works, you can check this Hugging Face, you can read this paper, and also you can take a free NLP course in Hugging Face transformers. And with that, thank you very much for your attention. So maybe I'll give, I don't know.
Wow. Yes. Thank you so much, Stephen. I think you've done an incredible job. But now, unfortunately, we've gone over time by almost, I think, 17 minutes. So I don't know whether we'll have time to respond to the questions on chat. But probably what I would request, because we have a Slack channel for guys who attended our last webinar. So probably I could send an invite for the guys who attended this webinar so that they can join, and then I'll post those questions, the questions in this chat. And then if possible now, Stephen, now you can respond to them on Slack. How is that?
That sounds good, but maybe if you can give maybe one room for maybe one question or two questions, maybe in 1 minute, it can be fine. Maybe 1 minute.
Okay, 1 minute. All right. Yes, Nicholas.
All right. Yeah, thank you very much for the presentation. It's an insight. I would like to know, in a situation where I want to use ChatGPT for my project, where maybe if there is a reference, ChatGPT able to give reference to my work.
Yes, yeah. When you use ChatGPT, you need to, in your references, you can just say use ChatGPT, and if you have a link, because the ChatGPT link is available, you just attach the link. Yeah, because nowadays people are using it to do their own research. You need to attach it as a link, so people they can go and see.
Okay. All right. Thank you.
Maybe the last question.
Okay, so in case of trying to fine-tune a model,
yes,
like the kind of data, if you have for instance, a file in a PDF, how do you use that to train it? I don't know.
If you have what?
A file in a PDF format, I don't know. Usually you use the CSV or the TST files.
Okay.
In a PDF format, how do you go?
So usually when you are fine-tuning this model, they have to take a very specific format. And so you might need to.
Okay, let me contextualize. I'm saying this because of math. For instance, if you want, some of these tests, TST document, you cannot incorporate sophisticated mathematics expressions. So maybe for something like that, how do you go about it?
So you might, I don't think maybe you are getting wrong by what you mean fine-tuning. And so fine-tuning is not actually trying to tell the model to do a math for you or things like that for you. So fine-tuning is like you have these large language models and you want to teach that model to do a specific NLP task. For example, machine translation.
Yeah, that's what I'm saying. I'm talking about how that data can be used.
Okay. So yes, my answer to this. So in the Hugging Face transformer, they usually document the format of the data. So what you can do is you need to transform that data to the acceptable format. You might need to work maybe extra hard to try and change your data from your current format to another format which the model understands. So the idea is every model has its own kind of format it accepts, maybe .csv, .text. So you have to work in transforming that model. They also give some examples. So you have to work and transform your data in that kind of text. Otherwise, you won't get what you expect.
Okay, thank you.
So it becomes your pre-processing step.
All right. Thank you so much. I think we have John, probably the last question. Please go ahead.
Yeah, nice presentation, Mr. Kilu.
Thank
Mine
you.
is actually not indeed a question, but actually a contribution.
Yes.
I know we can agree ChatGPT is getting acceptance in the field, but
Yeah.
still in academia is still gaining a lot of doubt. And indeed, most of the scholars and the academia fraternity, they still view it as a killer of creativity. So indeed, I wouldn't encourage anyone to kind of cite it, because indeed that is also viewed as a violation, and the Turnitin is actually nowadays customized to capture or else to detect any copying, probably plagiarism from ChatGPT. So in the field of academia, I would discourage anyone to probably think I can cite ChatGPT, because indeed you never do anything. ChatGPT always do it for you. With fine-tuning question, I think also Stephen did answer it very well. And I think in just a very simple word is more of customizing. This is getting something which is existing and making it work for what you want. So thank you very much. And I really enjoyed the presentation. And
Thank you very
thank you
much.
to
Thank you very much, John.
Yes, yes, yes. I also, second that. The session was just amazing, awesome. I also enjoyed following through. So thank you so much, guys.